Hello, today we are going to talk about IBM DB2 Data Warehouse. This is Group 3 and I'm Young. DB2 Warehouse is a data warehouse that controls over your data and applications. So it gets the data from each machine or IoT device, things like that. And it is extract and transform the data and then load to the data house. And then we can use the data for data analytics and um, business analytics. And it is compatible with Oracle and Netezza. Um, we're going to cover this agenda today. Um, it starts with architecture and technologies and key components and capabilities of cloud and ELT data transformation, and then we're gonna talk about security and key competitors and pricing.
Okay, hi. So I will talk about the overall architecture of IBM DB2, the data warehouse. DB2 is written in C, C++, assembly, and Java, which makes sense because, well, assembly, C, C++, and C are quite fast, and then Java probably, create some sort of functionality on top of that. It works with standard processors like 64-bit, 32-bit, Spark C, IBM Power microprocessors. I don't know what those are, but apparently it works with them. On the client side, local or remote applications are linked with DB2 client library. Local clients communicate using shared memory and semaphores. Remote clients use other protocols such as name pipelines or TCP/IP. Well, since they will be using the internet, they have to use TCP/IP, so that makes sense. On the server side, activity is controlled by engine dispatchable units or EDUs. The architecture of DB2 consists of different kinds of components, which I will also get in detail in the key components part. And it is mainly divided into DB2 client and DB2 server. DB2 server consists of different agents and sub-agents. The two important components are the prefetchers and the page cleaners, which maintain the data in buffer pools for fast and effective retrieval of data. While given that this is a data warehouse and this is our main purpose, it makes sense that these are the most important aspects of the architecture. Okay, key components. Um, First, DB2 client. It can either be a remote application or a local application, and of course, it's maintained by a library. Uh, and depending on the type, if it's remote or local, there are different ways, different techniques. If it's local, then semaphores and shared memory are used for communication. And for the remote calls, it is using like TCP/IP or named pipes. TCP/IP again, since it has to use the internet. Uh, the DB2 server is the second component. Uh, all the activities are controlled by EDUs or engine dispatchable units, and we can observe the different components of DB2 server and DB2 client server within these. Engine dispatchable units or the EDUs, all platforms execute the engine dispatchable units in form of threads. So threading kind of is also a parallel process. Once we consider that, we can see that this kind of makes sense for a warehouse. The most common types of engine dispatchable units are DB2 agents, and DB2J agents are responsible for performing and carry out nearly all of XQuery and SQL processing for DB2 server application. The other most profound and commonly present EDU is the page cleaners and the prefetchers. Again, these are all based on threads, and like they're highly parallel, like they're really easy to parallelize, and that creates a lot of speed. And again, they're bound by the um hardware itself. Subagents. A different set of subagents is used for serving the requests from client application processes. There is a facility and possibility that we can assign multiple subagents provided if the machine which we are using, DB2 server, has multiple processors. And it probably should have like multiple processors anyways, because like this is a server rack essentially, or that's the hope of it. So it may not have like a video processor card, but it will definitely have multiple processors. Uh, because like that's standard at this point. We are not in 1990s. DB server internally uses partition database environment One of the examples where we can use multiple subagents is systematic multiprocessing SMP, which is an environment and the multiple SMPs are capable of exploiting multiple processors at the same time. Again, they have the coordinate, otherwise it won't go fast. It has to be parallel. The pooling algorithm is responsible for managing the agents and subagents that are present on the inside of the DB2 server. This algorithm helps us minimize the destruction and construction of EDUs because, again, wasted resources. Uh, Buffer pool is the place where actual data resides. Those pools are the part of the memory of our database server, which stores the data related to the pages of user catalog data, index data temporarily. Thereafter, this data is moved to hard disks, but initially and while manipulating data, it's brought to these pools and modified and manipulated, which kind of again makes sense because like these are probably RAM, and it's much faster to process them here. And again, that's why it's probably called buffer. Again, they're one of the key parameters because it's essentially the bucket that we use to move data. Again, because it's a RAM, of course it will be easier. And again, this plays a lot of important role within the system. Prefetchers, again, like it's the job of prefetchers to move the data to buffer pool from hard disk before the data is being needed, used, or accessed of this application. One of the examples that will illustrate the use and benefit of buffer pools is that suppose we have large volumes of data that we need to scan, then in that case, if we were no prefetchers, then we would have to wait all required data to be moved to disk to the buffer pools of the server, which would take a long time and decrease performance of DB2 server to serve the request. It is the duty of agents of applications to send the read ahead request asynchronously to the prefetchers with the help of common prefetch queue. Again, these are pretty standard stuff for reading data. And working of prefetchers, client-side requests are implemented by prefetchers by using scatter read and big block input operations. I don't know what those are. When the prefetchers become available, they bring all the pages which are requested into the buffer pool from the disk. We can also strip the data across the disks, provided if we have multiple disks for storing data. Of course, we will allow those. The use of stripping the data helps us and enables the use of prefetchers to retrieve the data simultaneously from multiple disks. Again, everything's about parallelization, as you can see within this architecture, as it should be. And page cleaners. Exactly. I mean, like we have to also clear the data as we move, right? So it makes sense that there's a component for this. Data to hard disk from the buffer pool. They work with background of EDUs because they're independent of the other agents of application. The page cleaners are responsible for having the look at which pages are changed and updated, modified pages are written back to disk. It is the responsibility of page cleaners to make sure that required space is available in the buffer pools for the working of the prefetchers. Again, like they're the actual operation which opens up the space. If there are no independent page cleaners and the prefetchers in the DB, then the other agents of the application would have all operations related to read and write between disk storage and buffer pool. So this is the overall architecture. As you can see, it is really based on the components. That's why they're kind of intertwined. But again, it's highly parallelized and highly dependent on hardware. And it can scale depending on the organization's needs. And even, it can be done by outside contractors because it has the remote capability as well.
I'm gonna explain cloud and hybrid capabilities of IBM DB2 Warehouse. In terms of cloud capability, I summarized the features of IBM DB2 Warehouse in three ways. Firstly, it has elasticity. Users can customize storage and computing capacity of their data warehouse as they want. And secondly, it can directly build a variety of machine learning models, such as ANOVA, regression, and K-means, etc., without moving the data. Lastly, it can be deployed on IBM Cloud Platform or AWS. In addition, it supports the hybrid cloud solutions such as IBM Hybrid Data Management Solutions. So when an application is deployed on one DB2 warehouse, the workload can be easily moved to the other locations such as public cloud or private cloud or on premises. And okay, in terms of ETL and ELT data transformation capabilities, I'm gonna explain two tools. First one is IBM InfoSphere Data Stage. It supports ETL functions. By using this, clients can design data flows. And the second one is the DB2 Web Query Data Migrator ETL extension. It is compatible with other IBM systems and it supports both bulk load and incremental data updates. And Microsoft SQL Server and Oracle JD Edwards World Enterprise One can be used as data sources for the ETL process. Thank you.
Uh, IBM DB2 is actually first designed for commercial use for businesses, but lately they added individual access for developers as well. So actually, where database are good in security, but when it comes to the usage of databases, the security is very much important. Uh, that that to be very secure because lots of people are using it in different ways in different purposes. So the security is the main aspect. So DB2 technology complies with many security standards and enables you to manage access to your database. Uh, Database users manage of users that were given access to the database and the sole responsibility of the user or user with administrator role. And audit policy audit policy guidelines. So to manage access to your sensitive data, you can use a variety of authentications and access control mechanisms to establish rules and controls for acceptable data access, but to protect against an disclosure unknown or unacceptable behaviors, you can monitor data access by using the DB2 audit facility and IBM DB2 native encryption. So DB2 Warehouse uses native encryption to secure their data. So where that was all about the security, and the security is very important. And any database or any application that we are using, so we need to focus on the security aspect a lot. So the IBM DB2 competitors. So every business or every application or database or anything is introduced into the market. So the competitors are very. There are many other competitors as well. So the key competitors are Oracle database. So Oracle database is a multi-model database management system produced and marked by Oracle Corporation. It's a database commonly used for running online transaction processing, data warehousing, and mixed database workloads. And the Amazon Relational Database Service is another competitor of IBM DB2. So this Amazon Relational Database Services is a distributed relational database service by Amazon Web Servers. It is a web service running in the cloud designed to simplify the setup, operation, and scaling of a relational database for use in applications. And the another one is the Microsoft SQL Server, and the same time the SAP HAN Cloud, MySQL, PostgreSQL, Snowflake, and Google Cloud BigQuery. So BigQuery is a full managed service data warehouse that enables scalable analysis over petabytes of data. It is a platform as a service that supports querying using ANSI SQL. It is also has built-in machine learning capabilities. So these were the competitors of IBM DB2.
So this is DB2 Warehouse's pricing plan. Um, so they give five options, and two of them is with Amazon Web Services. Um, this flex option differs by disk storage and number of processor cores, which affects the performance of the product. And also, it varies the RAM capabilities. In conclusion, DB2 Warehouse is the one of the most common products in the market for data warehousing, and we can use it for business analytics or machine learning. Thank you.